there's a solar field. You can see all the solar cells. What if you could do it using software? So rather than having to have the same degree of efficiency and accuracy on the mirrors, you could use extremely cheap flat mirrors that would go and adjust themselves according to the direction of light using solar. This has been invented by or commercialized by a really interesting guy, Bill Gross. Who knows who Bill Gross is? Okay, so Bill Gross is amazing. He's not an energy guy at all. This is the man who essentially invented the business model for Google. He has an incubator in Pasadena outside Caltech called Idea Lab. He created a company called Go back in the 90s. Go created the essential idea that there would be paid search results, a kind of auction for search results. He sold it to Yahoo for around $2 billion, and using those $2 billion, he's been funding ideas like software-defined solar. So let's talk quickly about storage. Storage is a huge problem, as I was describing. There's no efficient way to do it. There are a couple of very radical ideas about how to approach it. This is probably the most radical idea. It comes from the university that is funding technology review. It's called artificial photosynthesis. Essentially, it allows light to either generate solar power and create some small wattage, or you can use colored materials. It sends a small charge into a catalyst combined of cobalt and phosphate. Oxygen rises off H2O off water. It splits the hydrogen from the water and creates hydrogen gas. Artificial photosynthesis. Sun plus water equals energy for free. Extraordinary thing. So you can store the energy in the form of helium, so it also solves the storage problem. This is a radical breakthrough technology for both storage and energy production. Created by a guy called Dan Nocera at MIT, who's been working on this problem for about 25 years. He's just at the commercialization stage now. He's founded a company to take it public. He is a radical man, very controversial in academic circles because he doesn't hide his light under a bushel. And particularly at places like MIT, you're meant to let the data speak for itself. But he's more of an entrepreneur at heart. Liquid batteries. This is the other solution for storing energy produced from intermittent sources like solar or wind. Again, this is an MIT technology. MIT at the moment is a little bit like it's like the Athens of battery technology at the moment. In addition to Dan and a gentleman I'm about to tell you about, there's Angela Belcher, who is creating spray-on batteries, and Yet-Ming Chang, who founded A123 Systems, which makes the batteries that go into most commercial electric cars at the moment. A123 Systems had the largest IPO in the United States in the last decade. Ooh. See, I told you I wrote this in. There's a little slideshow there to show you how liquid batteries works, which didn't work. So, but essentially, it works by mixing molten salts. It can occur at a grid level, which means that we can store energy produced for a city with 4 or 5 of these large-scale batteries. That's the guy who invented it, Don Sodaway, again at MIT. So even if we could create cheap electricity using solar, and even if we could store it using technologies like Dan Nocera's and Don Sodaway's, we wouldn't actually be able to transmit it. And that's because at the moment the network, electricity network of most industrialized nations is industrial in origin. It's dumb, and it essentially works on a one-to-many system. Electricity is generated in a large generating plant and is then sent out to all sorts of nodes around the network. For solar energy to really work, what you want is a distributed electricity system, a smart energy system. I'll be talking a bit more about this afternoon, but the important thing for this room to understand is that a smart meter that essentially makes your house use energy more efficiently really it's not enough. What we need is the same kind of routing system that the internet has, a smart routing system where energy can be shunted around the network according to individual needs and spikes and dips in demand. There are a whole bunch of companies working on this at the moment. It's probably the most funded area of efficient energy use at the moment, and I really could have selected any, but this is an interesting example. It's a company called Tres Amigas. This is a superstation in the middle of the United States, which is trying to go and join America's disparate grids into a single grid. So that's the company that's commercializing it, but there are companies working on this problem all over the world, including here in Israel. So one last bonus technology before I sit down. I've mainly talked about solar because it's the cheapest and most plentiful form of energy, but we in fact have a carbon neutral form of energy generation here at the moment. It is called nuclear, but we don't really know how to do it very well. The traveling wave reactor is the most far out idea I know at the moment in energy. So this was created by Nathan Myhrvold, the former chief technology officer of Microsoft, funded by Bill Gates. It's based upon a reactor design that is about 60 years old, called the Traveling Wave Reactor. The company is called TerraPower. A traveling wave reactor uses depleted uranium rather than enriched uranium or plutonium to set off a reaction in a sealed cement canister. The reactor can last around 200 years, producing energy in a thin film of fissionable material. And at the end of it, it's perfectly safe, eliminating any fears for proliferation. The wildest thing about this project is, of course, it's going to cost tens of billions of dollars to do, but Nathan and Bill have tens of billions of dollars, so they're going to build their own nuclear power plant in China to prove this can be done to the world. And they hope to have a prototype up and running by 2020. This is the first time that a private actor has ever created a nuclear power plant out of its pocket. I don't know if it's going to work, but I kind of admire Nathan and Bill for trying. So that is my brief tour around the gigantic problems that face us at the moment about providing energy to 9 billion people at the same standard of living which people enjoy now in the West with less carbon production. It's really not an easy problem. At the moment, the only companies who know how to go and produce energy at that scale are the hydrocarbons companies. And as I said, they believe that carbon is the product. So if we're to go and truly change the energy map, if we're going to bend the cost curve of energy generation, it's going to require not miracles, because miracles are things that you pray for, but it's going to require breakthroughs. And breakthroughs require significant investment by governments in discovery research, and then they require the enthusiasm and the creativity of the people in the room, entrepreneurs, to commercialize them. So in a sense, we're looking to you to save the world. Thank you.